Hello everyone, and welcome to the Numpy Arrays lecture. In this lecture, we're going to learn the various ways you can create a Numpy array using Python and the Numpy library. Let's go ahead and jump to the Jupyter Notebook to get started. Alright, here we are at the Jupyter Notebook. Numpy arrays are the main way we're going to be using the Numpy library throughout the course. And Numpy arrays essentially come in two flavors. They come as one-dimensional vectors or two-dimensional matrices, but they can both be called arrays if they're 1D or 2D. Let's go ahead and show how we can create a NumPy array from Python objects, such as a list. I'm going to go ahead and create an object, my list, 1, 2, 3. And if I go ahead and just display that list, notice I get out 1, 2, 3, and it's just a Python list. I'm going to go ahead and say import numpy as np, and then I can call np.array, and now I can cast that list as an array. And notice I get an array back as the container for that list object. And then I can actually assign this and then just call array off of that. So I can cast a normal Python list into an array. And that will return back a one-dimensional array. If I want to get a two-dimensional array or a matrix, I can cast a list of lists. So for example, I can say my underscore mat is equal to a list of 3 lists. So 1, 2, 3, 4, 5, 6, get rid of that extra comma, and then 7, 8, 9. So notice I get back a list of lists, and then if I cast that to an array, I will get back a two-dimensional array. And that's noted both by the way it's presented as the output, but also more importantly as the number of brackets shown on the closing and opening ends of this array. I have 2 sets of brackets, which will indicate that this is a two-dimensional array. It has 3 rows and 3 columns. And that's how you can cast normal Python lists or list of lists to a NumPy array. Usually, however, you'll probably be using NumPy's own built-in generation methods to actually create arrays a lot faster and a lot simpler. Let's go ahead and go through some of the most common ways to do that. The most common way you'll probably be creating a NumPy array is using np.arrange. And this is really similar to Python's own built-in range function. You'll go ahead and say np.arrange and then pass in a start and stop. So notice you have a start, a stop, and then a step size as a third argument. And this will return evenly spaced values within this given interval. So if I just say from 0 to 10, but remember, just like in Python's range, its indexing starts at 0, it will go up to, but not including to, 10. I'll get an array back from 0 all the way to 9. So I start at 0, and I go all the way up to, but not including 10, so I get 10 digits back, 0, 1, 2, 3, 4, 5, 6. And this essentially works just as Python's own range function. If I want to go from 0 all the way to 10, I have to say 0, 11. And that's what I get back out. And then finally, I can add a third argument, a step size. So if I want all the even numbers from 0 to 10, I could say 0, 11, and then add a step size of 2, so that I jump in steps of 2, so 0, 2, 4, 6, 8, 10. That means a range is going to be one of the most useful functions for quickly generating an array using NumPy. If you want specific types of arrays, there's other functions in NumPy that can help us do that. For instance, if we want to generate arrays of all zeros, we can say np.zeros, and you can pass in a single digit to get a one-dimensional vector out, or you can say np.zeros and pass a tuple of the dimensions you want. The first number is going to represent the number of rows, and the second number in that tuple is going to represent the number of columns. So for instance, if I want 2 rows by 3 columns, I pass in the tuple 2, 3, and I get back 2 rows by 3 columns. And this is noted by the brackets. Alright, if I want arrays of just pure ones, I can say np.ones, and similarly I can pass in either a single number for a one-dimensional array, or a tuple of dimensions for a two-dimensional matrix. That's ones and zeros. Another really useful built-in function is linspace. And linspace returns evenly spaced numbers over a specified interval. And it's important to not confuse linspace with arrange. Here we can see that arrange basically returns integers out from a start and a stop and a given step size. What linspace is going to do is it's actually going to take in a third argument of the number of points you want. Let me go ahead and show you what I mean by that. I can say np.linspace, and I'm going to pass in a start, a stop, and as a third argument, I'm going to pass in a number. So let's say I have a start of 0 and a stop of 5, and I want to get 10 evenly spaced points between 0 to 5. I can pass in a third argument 10, and this returns back a one-dimensional vector noted by the one set of brackets here of 10 evenly spaced points from 0 to 5. And I can change this third argument to whatever number I want. So if I want 100 evenly spaced points from 0 to 5, I can just pass that in, and that returns a much larger one-dimensional array. And keep in mind, even though it looks like this is two-dimensional as far as the way it's being printed out, you can tell it's one-dimensional by the fact that there's only one bracket here in front of the array. When you're dealing with 2 dimensions, you'll see that you have 2 sets of brackets on opening or closing at the ends. 3 dimensions will have 3 brackets, etc. Alright, so that's linspace. Again, don't confuse linspace with arrange. Linspace will take in this third argument as the number of points you want. Arrange will take in that argument as the step size you want. Let's go ahead and show how we can create an identity matrix using NumPy. We can say np.eye, and then you just pass in a single digit. An identity matrix, if you're not familiar, is a useful matrix when you're dealing with linear algebra problems, and it's basically just a two-dimensional square matrix, meaning the number of rows is the same as the number of columns, and you have a diagonal of ones, and everything else is zeros. And that's the reason it only takes a single digit as an argument, because identity matrix must be square as the output for np.eye. Alright, moving along, NumPy also has lots of ways to create arrays of random numbers, and we're going to use that often throughout the course, so let's go ahead and cover a few ways to do that. What you're going to go ahead and do is call np.random dot and then the random method. If you click tab, you'll see that there's actually quite a bit of methods, so we're going to go ahead and show you the most common ones. The first one is rand, R-A-N-D. And this is going to create an array of the given shape you pass in, and it's going to populate it with random samples from a uniform distribution over 0 to 1. And that means if I want just a one-dimensional array of random numbers uniformly distributed from 0 to 1, I can pass in a single digit, and I'll get back that one-dimensional array. If I want this to be two-dimensional, unlike the previous functions we worked with, instead of passing in a tuple, I'll actually just pass in the dimensions as separate arguments. So that means if I want a 5 by 5 matrix of random numbers, I just pass in 5, 5 instead of the tuple when working with these random libraries. Alright, if we want to return a sample or many samples from the standard normal distribution or a Gaussian distribution, instead of using rand, we can use randn. And that means I can say np.random.randn, and this will return numbers not from a uniform distribution from 0 to 1, but instead from a standard normal distribution centered around 0. And that means I can go ahead and pass in 2, and I get 2 random numbers from a standard normal distribution. And later on we'll see that plotting these out, not in this lecture, but once we get to data visualization, we'll go ahead and show you a nice normal distribution curve or a Gaussian distribution curve. And again, if I want this to be two-dimensional, I can just pass in 2 dimensions. So for a 4 by 4, I say 4, 4. And no, I don't pass the tuple here, I just pass in each dimension as a separate argument, and I can see by the set of 2 brackets that this is a two-dimensional matrix as an output. And the final random method of creating an array we're going to learn about is randint, and that returns random integers from a low to a high number. I'll go ahead and show you what we can do for that. You'll go ahead and say np.random, pass in rand int. You'll pass in, if I go ahead and click Shift Tab here, a low, a high, and then the actual size you want. So for instance, if you just say 1 to 100, you'll get a random integer between 1 and 100. And the low is inclusive and the high is exclusive, meaning 1 has the chance of being selected, but 100 does not. And if you want a particular number of random integers, you can pass that in as a third argument. So if I want 10 random integers from 1 to 100, but not including 100, I can just pass in 10 there, and there are 10 random integers, inclusive on the low end and exclusive on the high end. Okay, let's go ahead and discuss just a few useful attributes and methods of an array. In order to do this, I'm going to go ahead and create two new array objects. Let me go ahead and clear this and clear these cells. All right, I'm going to set ARR as my variable, and I will say this is equal to nparrange 25. So if I check what ARR looks like, here's a one-dimensional array of 0 up to 24. And then I'm going to say ranR is np.random, and it's going to be got to put a D there. Random integers from 0 to 50, let's go ahead and get 10 of those. So if I check out what ranR looks like this. You may get different values because it's randomly selected, but you should have just 10 integers there. All right, one of the most useful methods you can use on an array is the reshape method, and that's going to return an array containing the same data with a new shape. That means I can call my array dot and then the reshape method on it, reshape, and I pass in the new dimensions I want. So for example, if I want to reshape that array, remember ARR is 25 digits, 0 to 24, I can reshape it as a 5 by 5 array using reshape and then pass in the number of rows you want and the number of columns. Keep in mind, you'll get an error if you can't fill up that matrix completely. So for example, if I wanted 5 by 10, I would need 50 elements to do that. And I'm going to get an error here because the total size of the new array must be unchanged, meaning you need to fill up using only the digits you have or the elements you have. A nice simple way to check this is that the number of rows times the number of columns is equal to the actual number of elements. So 5 times 5 is equal to 25, and I know I have 25 elements in this array. Okay, let's go ahead and show a couple more useful methods for finding max or min values or to find their index location. And we'll go over a lot more operations later on in future lectures, but here are some useful ones for you to know. If we go ahead and check out our random array one more time, again, your numbers may be different, but for the sake of this exercise, that doesn't really matter. If you want to find the max value in your array, you can call the max method off of it, and this will return the maximum value of that array. Similarly, if you want to get the minimum value of your array, you can call the min method off of it. If we take a look at the array one more time, we can actually figure out the location of the max or min values by specifying argmax or argmin. Meaning, if I want to actually know at what index value is this max located at, 49, I can say ranR argmax, and that will return the index location of the max value. So I notice that 49 is located at index 3. So 0, 1, 2, 3, I have 49 there. And again, you can do the same thing with the min value. You can say argmin, and it will return the index location of the minimum value. So 6 is the index location of the minimum value, and the minimum value was 3 in this case. Okay, and quickly a few more useful methods and attributes. If you ever want to figure out the shape of a vector, you can say r.shape, and it will return back the shape. Notice here, I get 25, comma, and that's indicating that ARR, that array, was just a one-dimensional vector. If I go ahead and reshape it, so I'm going to say reshape to a 5 by 5, and I'm going to set that equal to r, or ARR. Notice now I have a two-dimensional matrix, if I call .shape off of that, notice I'm not putting parentheses, I'm just calling the attribute off of it. Now it reports back that it's a 5 by 5, so it's two-dimensional now. And the last useful attribute I want to show for now is the data type in this array. If you're ever curious of what data type you have in an array, you can just say ARR and type as an attribute dtype, and it will return the actual data type that's in your array. In this case, it's 32-bit integers. Okay, just as a quick review of everything we've gone over, we've shown you how to create NumPy arrays either by casting a list to a NumPy array or by using one of the built-in functions for NumPy arrays, such as arrange, zeros and ones, linspace, and and also the random generation methods. You call np.random and then rand_n, or randint, or some of the other random methods. Alright, and one last hint I want to show you. If you don't want to have to type in np.random.randint, what you can do is you can say from numpy.random import, and then whatever method or function you wanted to import. So if you wanted to import randint, you could go ahead and do that. And then instead of saying np.random.randint, you can just say randint, and now you have a reference for yourself. There you go. Okay. Again, remember you have the notebook with all the notes in case you want to reference any of this code or any of the notes that I actually spoke about throughout this lecture. Coming up next, we're going to learn about indexing and selection for NumPy arrays, as well as operations of NumPy arrays. Thanks everyone, and I'll see you at the next lecture.